Okay, so section 2.2, we're going to do it in 3 days. Okay, it's on what's called unit circle trigonometry. I'm just going to start out with that diagram. Okay, so what I've got up on the board, we've got the xy axes. Okay, we've got a circle. Okay, the center of the circle, that's the origin. And then I've marked some angles going around the circle. Okay, 0 is on the positive x-axis, 90 on the positive y, okay, 180 on the negative x, and 270 on the negative y. Right, so with unit circle trig, okay, first thing to kind of look at is the word unit. Okay? Everything that we do for the first part of this week is going to be on a circle where the radius is 1. Okay, we're going to use a circle of radius 1 because it makes everything easier than if the radius wasn't 1. Okay, so it's 1 unit in each direction. And then every angle that you can think of can somehow be represented as a coordinate. So that's the whole key with unit circle trig. You've got to take an angle and represent it as a location, okay, a coordinate on this circle. So let's try to do that for some of the coordinates we have here. Right, this is the origin. Okay, so think of this point at the center. That's 0, 0. Okay, let's start and see if we can get the coordinates for 0 degrees. Okay, keep in mind that it's 1 unit, okay, in every direction. So if you were at the origin and you moved 1 unit right, that's where we'd end up for 0 degrees. What's the coordinate if you go 1 to the right from the origin? Zach?
1, 0.
Yeah, 1, 0. That's the location. That's where 0 degrees is. It's just right 1 unit. Don't go up and down. Okay, how about 90 degrees? Yep, Charlie?
0, 1.
That's 0, 1. Okay, for that one, we don't go left and right. We just go up 1 unit. All right, and 180. Andy, what's the coordinates of 180?
-1, 0.
Yeah, we go left 1 unit, and then we stop. We don't go up and down. Okay, and then our last one, Jess, what would be the coordinates of 270? Yeah, in this case, don't go left and right. You go straight down 1 unit. Okay, and that's the idea what we're going to do with a whole bunch of angles. Okay, these are the easiest ones to do because you're just moving up, down, left, or right. When you have an angle that's kind of in the middle, we'll talk about how we can find it. Unit circle trig, we can't do every angle. Okay, we can only do angles that are multiples of 30. So we can do 30, 60, 90, 120, 150, so on. And we can also do angles that are multiples of 45. All right. So that would be angles like this. 90, 135, 180, 225. Some of these are also multiples of 30. Okay, there's a little bit of overlap. But the idea is any angle that's a multiple of 30 or 45, we can do it. All right, so if we had an angle that's not a multiple of 30 or 45, we are not going to use this to do it. All right. Any question about what kind of angles we can use this for? Even if you don't know yet how to write 30 degrees as a coordinate, that's okay. Actually, we're not even going to do that one today. All right. So there's 2 ways we can move on this circle. Okay, you got positive angles, negative angles. So if you're working on the unit circle and you move in a counterclockwise direction, okay, that's a positive angle. Okay, so counterclockwise, that's that way. If you move in a clockwise direction, that's a negative angle. Right, so what I'll do is I'll show you, I think I've shown you guys this before. Okay. Basically, it's the same diagram I have up on the board. Okay, it lets me draw different angles. Okay, as I go counterclockwise, they're positive. Okay, if we start going the other way, we go clockwise, get a negative angle. Okay, this top number is in degrees. What about this bottom number? What's that? Yeah, that's in radians. Okay, we might have to convert between degrees and radians, so that's still important from last week. All right. Now, let's take a look at, there's 90. Okay. Now, that angle, okay, ends at the same spot. All right, 450 and 90. They're basically the same thing when you draw them on paper. But when we have angles that are bigger than 360, it gets confusing to work with them, so we like to make them smaller. This one is exactly the same as 90. Anybody know what I could do to 450 to change it to 90? Think about what I'm doing on the board. Yeah, taking away one revolution. Okay, I'm just backing it back down one revolution, which is the same as subtracting, someone just said it, 360. All right, so if you've got an angle that's too big to work with, okay, you're going to subtract 360. You might even have to do it more than once. Right, do it as many times as you need to till you finally get your angle somewhere between 0 and 360. But don't make it negative. Here's another example. Okay, if I asked you to draw the angle that's 1,350 degrees, all right, we know we've gone around a few extra times. So what we'll do, just subtract 360 till we finally get it small enough. It's that angle that I just showed you. It's exactly the same as 270. Now, what do you think you could do with an angle that's negative? Yeah, we can add 360 as many times as we want to find out what it would be the same as. All right? We always want everything between 0 and 360. All right, so if you've got a negative angle and you want to make it positive, which usually, if it's positive, it's a little easier in your head to visualize, just add 360. Okay, and you can add 360 as many times as you need to. But stop once it's between 0 and 360. I can show you that I'll show you the same idea here about adding 360, doing it on the picture. Here's an angle. Let's do it like this. Okay, negative 540. And I say, okay, well, what's that the same as? Okay, how can we rewrite it so it's between 0 and 360? Just add 360 one time. Now, did that get it to be positive? No, so what do we do? Yeah, do it one more time. Add 360 one more time. Okay, so you're still ending at exactly the same spot. Okay, that little ball is right on the left-hand side. You're just finally making it so your angle is positive rather than negative. Okay, any question on that idea? All right, so once we can figure out where something is on the unit circle, okay, once we can find its coordinate, okay, its location, then we can use that coordinate to do some trig. Okay, and there are 6 different functions that we use in trig. Anybody know some of the functions we use in trig? There's buttons for them on the calculator too. Yeah?
Sine, cosine,
Yep.
and tangent.
Sine, cosine, and tangent. That's the first 3 we're going to look at. Does anybody know the other 3? Yeah?
The native sine? No, something opposite of sine cosine.
Yeah, it's when you take all of these and you flip them. Take the reciprocal of each one. Andy, do you remember one of them?
Inverse sine. Or,
No, not inverse sine.
Cosecant.
Cosecant. Yep. Secant
And cotangent.
and cotangent. Yeah. All right. These are the 3 that we use the most often. If you have a calculator, you'll see buttons for those. Okay. Sine is abbreviated SIN. Cosine, COS. Tangent, TAN. I'll use these abbreviations from now on. All right. And now to figure out what the sine, what the cosine, and what the tangent is, you have to know your coordinate. Okay? You have to have already found where that is on the unit circle. And now a coordinate has how many values in it?
2.
2. What's the first one? That's your
X.
x, and your second one?
Y.
That's your y. So you got to find out your x and your y. Okay? And for sine, once you know your x and your y, you don't even need the x. All you need is the y. Okay? For cosine, you need the x. Okay? Whatever the x value is, that's the cosine. And the tangent, you need both. Y divided by x. Okay? And this symbol here, theta, that's what you're plugging into the sine function. All right, so it's kind of like if I said, take the square root. I can't just say take the square root and you give me an answer. I got to tell you what number I want you to plug into the square root function. Okay, same idea with sine. I can't just say, press sine and tell me the answer. Well, the sine of what? You have to plug in a number into it. Right? So that's what this is. That's the angle that we're plugging into the sine function. So I could plug in like 75 degrees, and that's the answer. Or actually, I'm in radians. Okay, we'll talk more about making sure you're in the right mode, because that makes a big difference. All right. Now, earlier I said if you want to get the other 3, which are cosecant, secant, and cotangent, yeah, we do have to get those. Yep, we have to get those. Jackie, earlier I said all you have to do is take this and flip it, but there's no number on the bottom here. But what can you always put as a number on the bottom? Yeah. So you could put it over 1, and what do you get if you flip that?
1 over y.
Yeah, you get 1 over y. Okay, and that's your cosecant. Jake, using kind of the same idea, what do you think your secant is?
1 over x.
Yeah, it's 1 over x. Okay, and Dakota, what about the last one? If you flip y over x,
X over Y.
you get x over y. So these are the 6 formulas that you need to know for the test this week. And I think those are it. And you only really have to remember the first 3. If you can remember the first 3, and then remember I just flip it, and flip it to get the other 3. Okay, and the abbreviations, okay, that's abbreviated COT for cotangent. Okay, SEC. So usually we just try to use the first 3 letters. But can I do that for cosecant? No, because I've already used COS somewhere else. So they go Cosecant, CSC. Okay, so that's the 6 definitions of the trig functions on a unit circle. Okay. If you've done this before and you've used opposite, adjacent, and hypotenuse, anybody use those terms before? You heard those? Yeah, those, that's a different way to do it. It's really the same as this stuff. Okay, the 4 angles that I had up earlier, the very first 4, those have a special name because all of these angles land right on an axis, and the axes are what separate your plane into quadrants. Okay, these are called the quadrantal angles. 0, 90, 180, and 270. It's just a special name for those 4 angles. Questions on those definitions? Okay. So how do you actually use the unit circle and those definitions to find a trig function? First thing we're going to do is find the coordinates on the circle that represent the angle. Right now, you guys know how to do 4 angles. You know how to find the coordinates for 0, 90, 180, and 270. Okay, those, I'll put this right back. Those are the very first angles we wrote. Okay, those are the only 4 you know how to do right now. Okay, for today, if the point is going to get any more complicated than 1, 0 or 0, 1, I'm going to give it to you. But if I don't give you the point, you have to locate it. You have to find it yourself. So I won't be giving you any that are that hard to find today. Only those 4. Okay, after you find that point, then you're going to know your x value. You're going to know your y value. Plug in your x and y value into the definitions we just had on the other page to find whatever trig function they're looking for. Bless you. Okay, so as we go through and practice, we'll practice all 6. We'll find the sine, the cosine, the tangent, the secant, the cosecant, and the cotangent. I am not going to ask you to find all 6 in the same problem on the test. Okay, that'd be a lot in one problem. And that's pretty much it for the notes. The rest of what we do is just going to be examples. Okay, try to keep this up while we do our first example. So I'll kind of walk you through the first one, and then after that I'll call on some people to help you. Okay, step 1, locate the point on the unit circle. Okay. Sometimes you are given the point. In this problem, they are giving you the point. Okay. This is not the coordinate for 0, 90, 180, or 270. If it was, it would have 1s and 0s in it. Okay. It would look like one of these. So this coordinate represents some other angle we don't know yet. And in fact, we're never going to know what this angle is. We don't need to. Okay. We're just going to describe some things about the angle. We're never going to know how big this angle actually is. Is it 90 degrees, 150? We don't know. Okay. And it's kind of like if you met someone on the street. You don't need to know their name to describe them. You can just look at somebody and describe what color shirt they're wearing, eye color, hair color, height. You don't need to know their name to do any of that. Well, think of these as eye color, hair color. They're different things that describe the angle, but you don't need to know how big the angle is to describe it. You just need this coordinate. That's it. All right, so they're asking for all 6. Okay, so what we'll do is just fill in to these 6 formulas those 2 numbers. All right, so let's start with sine. Okay, Paige, what's the definition of sine? What letter is that equal to? Y, yeah. And in this case, what number is y? Square root of 3 over 2. That's it. That's your sine. Square root of 3 over 2. Sine and cosine are the easiest ones to do. You don't have to flip it. There's no division. You're done. Okay, Nathan, what is cosine equal to? Which letter?
X.
Good, x. And what's x in this case?
-1 over 2.
Yep. And that's it. That's your cosine. Okay, the rest of them are either going to involve dividing fractions or flipping. Okay. So our tangent. Charlie, what's the formula for tangent? Good, it's y over x. So there's y divided by x. Okay, what happens here when you've got the same denominator in each fraction? What can I do to that denominator? Yeah, it cancels out. Some people, when they divide fractions, they take the bottom one, flip it, and multiply by the top. Well, if you flipped it, the 2 would go to the top, and the 2's would cancel out. Okay. And all that I'm left with here is square root 3 divided by -1. Okay. Once I get the 3 on the left, all I have to do is take each one of these and flip them to get the 3 on the right. The only thing we got to be careful when we flip, we don't want to leave square roots in the bottom. Okay, I think we might have mentioned that last week. But that's the only thing that could happen we got to fix. So John, what do you get when you flip square root 3 over 2?
2 over square root 3.
Yep. So we're going to start out like that. And do you remember what you can multiply the top and bottom by to fix that square root in the bottom?
3.
Close, not 3, but square root of 3. All right, so flipping that's the trig part, okay, to get the cosecant. Now this is just cleaning up, using a little arithmetic here to fix that square root in the bottom. All right, so in the top, we're going to get 2 times the square root of 3. How about in the bottom? 3. Square root of 3 times square root of 3. That's the square root of 9. Or 3. Okay, Ben, how about when I flip my cosine to get secant?
You would just flip them so they 2 over -1.
Yeah, and what's 2 divided by -1?
2. Right? No. Drawing a blank, hang on.
Well, it's the same as 2 divided by 1, except it's a negative instead of a positive.
So it would be 2. Right? It's 2, -2.
You're dividing a positive by a negative, so that's a negative.
-2.
-2. Okay, so when you flip -1 over 2, you get -2 over 1. And this time, there's no square root. Okay, so that one's done. And the last one. Okay, how do I flip that? There's no fraction there. What can I do with that one? About Tiffany?
What you could do is wouldn't you just leave it the way it is, like square root of 3 over 3? Like you don't split the 1?
So what did you want to put what number down here to make it a fraction? There's only one number you can put. Only one number you can put.
Oh, 1.
Yeah, 1.
My bad, I did the wrong one.
All right. So now we can flip it. Okay, if it's negative when you start and you flip it, it stays negative. Flipping doesn't change the negative. So this time it's -1 over the square root of 3. And now we've got the same thing we had up above with the cosecant. We got to fix that. So Zach, what could I multiply top and bottom by to fix it?
Square root of 3.
Yeah. Square root of 3 over square root of 3. And can you tell me my final answer?
-1 times the square root of 3 over 3.
Perfect. Negative square root 3 over 3. Okay, if this was on a test, this would be 6 separate problems on the test. Okay, each one would be its own problem. You won't have all 6 in one problem like this. Okay, any question on that? That's pretty much all we're doing. Yep. Okay, here's another one, same directions. Again, I'm not telling you what the angle is that this coordinate represents. But does anybody have an idea what that might be? It's an angle where x is the same and y is the same. Think about if you drew that on the circle and you went right the same amount and up the same amount. It is. That's the coordinate for a 45-degree angle. Good job. Okay, but for today, I'm not going to explain to you how to get that. Okay, that'll be tomorrow. Okay, so again, we know it's a 45, but you don't need to know that. All you need is the location. That's the most important thing. Where is the angle on the unit circle? All right, Chris, could you tell me what my sine would be here?
The square root of 2 divided by 2.
Yeah, and since they're both the same, which one did you pick, x or y? Y, yeah. Okay, in this case, if you switched them, it wouldn't mess it up. But, yep, so you got that right. Pick the y. Alex, what about my cosine?
Square root of 2 over 2.
Yep, which one did you pick there?
X.
Good, he picked the x. And now the tangent. Okay, take y and divide by x. So that's square root of 2 over 2. Divided by square root 2 over 2. Hannah, what do you get when you divide two things that are the same?
0.
Think about like 3 divided by 3. Yeah, we get 1. Okay, if you want, some people when they divide fractions, they keep the top the same. And they take the bottom one and they flip it. Okay, how many people have done it that way before? Yeah. Well, if you want to do that, that's fine. 2 goes into 2 once. And then square root of 2 goes into itself once. So what happens is everything cancels out and you get 1 over 1. Okay? But if you just notice that right away, it's a little quicker. Okay, so there's our first 3. And Jake, what do I do to get cosecant? Which one of those do I flip?
You flip sine.
Yep, that's why I lined them up the way I did. So you always flip the one that's across from it. Okay, flip the sign. Callie, can you flip that for me? Don't worry if you get a square root in the bottom. We'll fix it.
2 over the square root of 2.
All right, so we start out 2 over the square root of 2. And Analia, what would I multiply top and bottom by?
Square root of
Go ahead. Square root of 2. Square root of 2. Okay, watch what happens here. You get 2 times the square root of 2 in the top. Okay, what do you get in the bottom? 2. Is there any number that's outside the square root we can cancel? Yeah. Get the same number in the top and the bottom on the outside. Don't ever touch the number under the root, just what's on the outside. So my final answer is just square root of 2. Okay, what's my secant going to be?
Same thing.
Yeah, why is it the same thing? Yeah, if the sine and the cosine are the same, then your secant and your cosecant are also the same. So why waste the time to do all the work again? Right? And cotangent. 1. Okay, when you take the number 1 and you flip it, it stays the same. There's two numbers you can flip and they stay the same. 1, and does anyone know the other number? -1. Okay, those are the two numbers. If you flip them, they don't change. Questions on that? All right, let's try one more with the coordinate, and then we'll do a different one. Okay, try that one on your own. Okay, so this coordinate represents some angle somewhere on the circle. We don't know what the angle is, and we don't need to. I just want you to find the 6 trig functions for that angle. All right, so take a second, we'll do that, and then try a couple more. All right, start off with the first two, sine and cosine. Those are always the easiest. Just copy them down from your coordinate. Biggest mistake I see people make with this on the test is they switch them. And then if you switch those, everything usually comes out wrong. Okay? All right, so sine, that's our y, and cosine is our x. Okay, how many people had at least those two? Are those good? All right. Now for tangent, you're going to take y and divide by x. So you're taking the value for sine, and you're dividing by cosine. So -1/3 divided by, oh, is it over 3? Yeah, thank you. I think the last one we had 2's. 2 square root 2 over 3. Okay, what can I cancel out there? Yep, whenever you have the same denominator, okay, either flip and multiply or just cancel them out. All right, so now we get -1 over 2 square root of 2. And what's the problem with this denominator? Is it the 2 or the square root of 2? Yeah, it's just the square root of 2. So just multiply top and bottom by what the problem is. Okay, it's just the square root of 2. Okay, in the top, that'll give me -square root of 2. And in the bottom, I'm going to have 2 times, what's the square root of 2 times the square root of 2? Yeah? Yeah, that's going to be the final answer. Yep. The square root of 2 times the square root of 2 is 2. You had another 2 in the bottom, and 2 times 2 gives you 4. Anybody get that? Good. You got that? Can I reduce by 2? That number under the root and the 4? No. Okay, that square root, think of that, it's protecting the 2. You can't do anything to the number under the root. Don't touch it. Okay, but save this. Okay, we're going to come back to that in a second. Okay, so it's good to still keep that down there. Okay, cosecant. Zach, what do we get for that one?
-3.
Yep. Okay, that one's quick. No root we have to flip. Okay, for secant, I got to flip that. And it's basically the same problem I just had with tangent. Multiply top and bottom by root 2. Okay, denominator is going to be 4. Any question on how to get that again? Same way we just got it. And then in the top, Andy, what will I have?
3 square roots of 2.
3 square roots of 2. Okay, now the cotangent. Well, we've got 2 choices of things we can flip. We had this answer, and then we have the other answer. The 2 things that I've circled, just circle in a different color. What's in red and what's in blue are exactly the same thing. The only reason we didn't leave it like this is because it had a root in the bottom. Which one would be better to flip? The one that's circled in red or blue?
In blue.
Yeah, why is the one in blue better one to flip?
Because you'll put your square root at the top that way.
Right. If you flip the one in blue, you're going to be done in one step. Done. If you flip the one in red, that's okay. You're just going to send the square root back to the bottom, and you're going to have to fix it again, and you're going to end up getting that as your final answer. Okay. Any question on the type where they give you the coordinate? All right. Okay, what's different about this one? Yeah, you've got the angle. Okay, this angle doesn't help you at all. You need the coordinate for 90. Okay, so we got to find the location for 90. Okay, if I can't remember it, what I usually do, sketch my circle, and 90 is the one at the top. So then I think, how would I get to 90? I go up 1. Okay, Dakota, what's the coordinate if you go up 1?
0, 1.
Yeah, 0, 1. Now, this is just going to be like the other problems, except super easy, no square roots. All zeros and ones. Right. Paige, what's my sign going to be?
0.
Careful, what letter is sine?
Is that 1?
Yeah, sine is y, so that's 1. Okay, my cosine is going to be 0. Okay, Lauren, what about my tangent? Yep, it's going to be 1 over 0. And what do you get when you divide by 0?
1.
No?
Undefined.
Undefined. Okay, that's undefined. You cannot do the tangent of 90. Can't do it. And that's why, because you'd be trying to divide by 0. All right. Now we'll flip. What do you get when you flip 1? 1. How about when you flip 0? Undefined. Okay, if you want, think of it as a fraction. When you flip 0 over 1, you get 1 over 0. That's undefined. And what about if you flip undefined? What's 0 divided by 1? Yeah, 0 divided by 1 is 0. Think about if you take $0 and split it up between any number of people. Everybody gets 0. Okay, any question on that one? Yep, that one's not bad. No square roots in it. For this one, we're not going to do the other 3. Okay, I'm only going to ask for sine, cosine, and tangent. And we'll finish with that one. Okay, what's different about this one?
It's in radians.
Yeah, they're giving us the angle, just like they did in the last problem, except this is in radians. So what might make this a little easier if we take that and what? Yeah, we'll make it degrees. Okay, anybody remember from last week what you multiplied by to change that? Yeah?
180 over pi.
Nice. 180 over pi. 3 times 180, that's 540 degrees. Now, that angle's kind of big to work with. So what was the trick I said you can do to make angles smaller?
Subtract 360.
Subtract 360. So 540 is the same, whoops, as 180. Okay, now we've got the angle down to a manageable size. We can figure out the coordinate.
How'd you get 180?
So take 540 and subtract 360. It's like subtracting 1 revolution. Okay, now where is 180? Is that one up, down, left, or right? That's left. Okay, and what are your coordinates if you go left? -1, 0. That's it. That's the hard part. Now we just find our values. Sine is y. Cosine is x. And my last one, my tangent. And how'd you get that, Kaylin? So you might have to change from radians to degrees. There's a problem where you had to do it. Okay, and last one. Okay, let's just find the three trig functions of 11 pi over 2. Okay, keep in mind, if I don't give you the angle, it's got to come out to one of the four that you know how to do. 0, 90, 180, or 270. Can't be anything other than one of those four for today. All right, so Chris, what do I multiply that by to change to degrees?
180.
Over
1
pi.
Oh.
Yeah, you put it over pi. Okay, Nathan, what cancels out there?
Pi.
Good. Pi's are gone. If you want to reduce it further by hand, you can. I'd just type it in. Just do 11 times 180, divide by 2. So that's 990. Okay, 990, kind of a big angle. Kind of hard to visualize where that would be. How do we make it smaller? Okay. That's still kind of big. Do it again. 270. Okay, where's 270 on the circle? Yep, down. 0, -1. Okay, the quadrantal angles are super easy because it's all ones and zeros. Never have any square roots with them. Okay, and Brandon, can you give me my sine, cosine, and tangent?
-1, 0, -1.
What would be on top? -1 or 0?
0.
Y over x. Okay, it's always almost the way you write it. Y over x. And what do you get when you divide by 0?
Undefined.
Undefined. Yep. All right, so that's the first part of unit circle trig. Basically what we're going to do all week. Okay, same idea tomorrow. In fact, I think tomorrow you might even find it a little easier than today. Okay, so the homework, it's on 116. Okay, try 11 to 27 odd and 22. Okay, we'll take a look at that tomorrow.